Okay, so let's continue. Yesterday we saw what is OSI model. We have seen first three layer, which is physical layer, data link layer, and network layer. Okay, today we'll start with transport layer, which is layer number 4. What have we seen in network layer? What what do we do in network layer?
We communicate with IP address.
Communicate with IP.
Router.
Okay, router is involved.
Router is
Okay.
involved, yes.
Mhm. Anything else?
Data, there's a source IP and then there's a destination IP.
Okay. What
All
is that
three
thing called?
And we call that frame.
frame.
Is it frame or is it packet?
Packets,
Yes, because frame is on layer 2.
two.
Okay. Remember that part. Alright, now talking about your layer number 4. In layer number 4, you will see few things, few concepts like TCP, UDP, ports. Just giving you an overview, okay, before we start. There is Nmap, there is firewall, there is DDoS, there is port scanning, all these stuffs. Okay.
Mhm.
So understand, let's what do we mean by transport layer? Now suppose your laptop is doing all the things at same time. For example, watching YouTube, using WhatsApp web, downloading any file from internet, receiving an email. How does your laptop know which data belong to which application? Have you thought of it? I have around around 15 tabs open on my browser right now. Around
Mhm.
15 tabs. One of it is YouTube, one of it is WhatsApp web, one is Telegram, one is Zoom meeting, another is email. So how does my laptop know which data belongs to which application? That is where this layer number 4 comes into picture.
Transport layer.
That is transport layer, OSI layer number 4. So the job of this layer is to ensure that data reaches correct application, and if required it arrives reliably. I'll tell you the difference between TCP and UDP. So
And
whatever
arrive.
to ensure the data reaches the correct application, and if it is required it arrives reliably.
What was the last word? It arrives.
Reliably. Reliably.
Oh,
Reliable.
okay, reliable. Okay.
Like whatever the tab or website we open, it should tells us about that, not something else. Like we're using Google and it's showing us YouTube, that kind of a thing.
No,
Reliability.
reliably means making sure that the things that you're now, for example, take an example of courier manager. Okay,
Mhm.
let's say layer 3 got you the parcel to the correct building, right? To the correct destination, your network layer. Now, what will this layer do? He will make sure that you get into the correct room, that parcel, that courier gets into the correct room.
Sure.
Let's suppose another example I'll give you. Suppose there is a company building. Okay, that building has HR department, there is finance, there is IT, there is sales department, right? So mail arrives at the building. A parcel, a courier mail arrives at the building. Now someone must decide which department this mail goes into, right? Is it belonging to HR department? Is it belonging to finance? Is it to IT? So depends on layer number 4, that is our transport layer. It is making sure that the delivery which is happening is reliable if it is required. Therefore, TCP and UDP comes into picture. We'll talk about TCP UDP, so this concept will get clear. Now first, this is important topic in layer number 4, which is ports. I'll write it here. Ports. What do you understand by port? Yes,
Ports is the entry point.
entry point. Okay. Is it only entry point?
Destination too.
Hmm. It is entry as well as exit point.
Exit.
Now consider port as a logical door. Nothing like port exists physically. It's a logical door which is used by any application to send or to receive the data. That is called as port. Note this thing down. A logical door used by applications to run their services, to send or to receive data. That is a port. Okay. For example, you have an IP address 192.168.1.10. Now, for example, this is your IP address. So many applications are running on this IP address. It can be Chrome, Zoom, Outlook, Teams, WhatsApp. But how does traffic know where to go? Answer is port.
Port.
So famous port numbers are there. There is HTTP, that is port number 80. There is HTTPS. You write it in URL, right? HTTPS colon colon slash and then you type www.google.com. That is 443. HTTPS. FTP is 21. SSH is 22. I can go on and on. There are so many ports available. So when you open https colon slash slash google.com, browser automatically uses port 443 because https uses port number 443. It belongs to 443. Okay. Clear what is port? It is nothing but a logical gateway or logical entry exit point for your applications to send and receive data. Okay. Now this transport layer, this has two major protocols. Protocols means set of rules. Very famous. One is called TCP and other one is called UDP. Interviewers, they will ask you about TCP, UDP all the time. Most famous concept, TCP and UDP. Now TCP means Transmission Control Protocol. I'll write it here for you. And UDP means User Datagram Protocol. Now, what are this TCP and UDP? They are nothing but just protocols. Let's say you want to send a courier. After sending a courier, would you like a confirmation that your courier has been successfully delivered? Yes or no?
Yes.
Yes, that is TCP. When you get a confirmation that your package, whichever you have sent, it is delivered, that is TCP. Therefore, TCP is reliable. You get an acknowledgement that the data that you have sent is received correctly. It is received reliably. If you remember the definition of transport layer, this is where reliably comes into picture. If required. Now, if not required, UDP. What happens in TCP is it follows a sequence. See, I'm just giving you a simple example. This is our data 1, 2, 3, 4, 5. There are 5 chunks. Okay, 5 chunks means 5 blocks 1, 2, 3, 4, and 5. This is at sender end and this is at receiver end. Now, what if data, the way you send the data should be received in the same manner, right? What if this is hello written at receiving end? If user receives something like this, will he understand anything? No, right? What is the sequence of this? First, second, third, fourth, and fifth, right? So is it the correct way, correct manner in which the data is being received? No. So this is not reliable. Order is not maintained. But when you use TCP, TCP will make sure that whatever data you are sending, now for example, if this packet dropped out while sending due to any reason, due to network issue, electricity issue, or any weather forecast issue, anything, this packet unfortunately dropped out. He will make sure that this product or this packet is delivered correctly. He will ask sender to resend this packet so that it is received correctly at the user end. So you get a reliability that the data you are sending is in proper reliable manner and it is maintaining the sequence. So error checking is also done here. It is going to detect problems and you get good acknowledgements. Receiver, they'll confirm that yes, I have got the data. So your web browsing, email, after sending email you get an acknowledgement, right? Your data has been sent successfully. You see it in the send panel. File transfer, any let's say you are buying something on amazon.com on the website. Tomorrow you decide to buy a football from Amazon. You get an acknowledgement, right? After buying that product, after making that payment, you get a receipt, you get an invoice. What is that? That is like an acknowledgement that you are getting. Because data loss is not acceptable for TCP, not at all. But the brother of TCP is UDP. This is user datagram protocol. This is fast, but this is not reliable. He will send the data. Imagine um, any live streaming or any have you seen any live streaming? Let's say you are watching a cricket
Yes.
match
Hmm.
and it's going on TV right now. Due to some issue, due to some minor glitch, you missed out one or two balls. Now the deliveries which were missed, are they going to show these deliveries again while watching the cricket, live cricket?
No.
No. Imagine me making an announcement on a loudspeaker. That message was sent. There was no confirmation, no acknowledgement, no guarantee of it, nothing. So you don't have that overhead of receiving an acknowledgement. This is faster medium. Now, if this data is being sent to the receiver, until and unless you get an acknowledgement, he won't send the next data, right? So you'll have to wait. That is TCP. But UDP, he doesn't care. He just sends it. It's like me teaching you guys anything, making I'm not even interested in like understanding if you're getting the topic, you're not getting it. I'm just teaching. I'm taking those 1.5 hours and I am ending the session. What is this? This is UDP. Now I'm talking about transport layer. I'm teaching you. Okay. After teaching, I'm waiting. I'm making sure that you have understood the concept. Then I'm moving to the next layer. What is this? Getting an acknowledgement from you. This is TCP. Now, which is more reliable, TCP or UDP?
TCP.
TC,
TCP, of course. Who's more faster, TCP or UDP?
UDP,
UDP. Who does not give an acknowledgement?
UTP.
UDP. Who does not do a retransmission?
UTP.
UDP, not TCP. Retransmission.
Okay, UDP.
Okay.
So why do we have this protocol then, the UTP?
For faster medium. Now,
So can you give an example, like when do we use this UTP?
live
Because
streaming, best example for
uh,
live streaming. See, if you're watching a football match and you miss out on 1 minute due to channel issues or maybe network issues, your internet was slow. Are they going to show you that 1 minute of football match again? No. So TCP is reliable, UDP is not reliable. TCP is slower compared to UDP. Who gives an acknowledgement? TCP. UDP, you do not get any acknowledgement. Who guarantees ordered delivery? TCP. There is no ordered mechanism. This data, if you see this data, this can be a case in UDP. It doesn't care. He's just sending the data, no matter how it is received at the receiving end. So this can be a case of UDP. All the packets are reached. Yes, but is the sequence mattering? No, not at all. Okay. For that, you will have to understand one concept which is called three-way handshake. Okay, since we are talking about it, I'll just give you a quick idea of what is three-way handshake. See, this is sender, this is receiver. What happens is while establishing any communication, okay, for example, I am talking to you for the first time, or my device is talking to your device for the first time. We want to communicate. Now, whenever this device wants to communicate for the first time, there is always a handshake taking place. You greet each other while you meet first time, right? You shake hands. What is that? It's a way to make sure the other party recognizes you. So, sender party, what happens is he'll send a packet which is called SYN packet. It's like asking, hey, how are you? So, what will this receiving party do? He will respond to this. He'll send SYN plus acknowledgement packet. SYN ack. He's like, hey, I'm good. How about you? He responds to this. I'm great. Now let's communicate. This is called three-way handshake. So this ensures that your connection, whichever you are establishing from sender to receiver, is reliable, connection oriented. Now this three-way handshake is not taking place in UDP. No, it's just sending data. There is no contract or pact happening between sender and receiver. So your WhatsApp calls, just giving you an example, your WhatsApp or your video calls, if there is a minor glitch, do you see what exactly happens in that glitch timing? Do you get to know anything what happened exactly? No, that is UDP. But your banking application, if something goes wrong in that banking application, that thing has to be reverted and retransmitted, right? A reliable connection communication is required there. That is TCP. So which one of this is connection oriented? I repeat my question. Which one of this, like TCP or UDP, which one is connection oriented?
TCP.
TCP.
TCP. Connection oriented means you are establishing a communication first. You are doing this three-way handshake first, and then you're talking. In UDP, this is called connectionless. This is connectionless protocol. So as soon as I enter the class, first I greet you, right? Good evening, how are you doing today? I'm establishing a communication with you first, making sure it is reliable. UDP, I'll directly start teaching, making sure you understand, you don't understand. I'll talk about this topic, I'll end the session. I won't even give you chance to retransmit or ask question, making sure acknowledgements are received. No, nothing is done in UDP. So this mechanism is faster compared to TCP. UDP is faster because it does not follow handshake methods. Clear? Anything that you want me to repeat here? This is also one of the famous questions. Okay, TCP handshake. Before communication starts, TCP is going to perform handshake. So there are three packets: SYN packet, SYN acknowledgement, and then acknowledgement. This is actually client and server. After this handshake is performed, then your data transfer begins. Like after me entering into the class, after I greet you, then I start teaching. Same thing. I'll start teaching, then after my teaching is done, my communication ends, my connection ends. Okay, clear? What is
Yes.
TCP? What is UDP?
Yes, sir.
Okay. Now this method or this thing which I have shown you here. Okay, this, I'm not sure if you're able to see my cursor. If you can see this cursor, this thing is technically called segmentation. Okay,
Mm.
I'll draw a new diagram here. Suppose you want to transmit a 100 MB file. So what will transport layer do? It will break it into pieces. 100 MB is too much, right, to transmit. So it will break that file into multiple pieces. And now it gets easier to transmit, right? This can be 20 MB. This can be 20 MB. This can be 30 MB, 50 MB, whatever it is. So instead of sending 100 MBs together, you're just breaking it into smaller pieces and transmitting it. Something like this. So this is much easier to transport. So if something goes wrong, something fails, you can resend it, right? Instead of sending 100, now imagine if 100 MBs data is being sent and if this fails, You'll have to resend this data again, right? 100 MBs. From scratch, you will have to start. But if this is divided, and if something fails, maybe you'll have to transmit only 20 MBs. This is much easier, right? To transmit and to maintain. This is called segmentation. Segment. This is called segment. One chunk, piece of data. So your layer 1 had bits, layer 2 had frames, layer 3 had packets, and now layer 4 is having segments. Data unit for layer 4 is segment. This segment. Clear? Is transport layer clear to you? Anything that you want me to repeat? Any term which you find new and confusing, want me to repeat here?
So
Take
this
1 minute of time.
segmentation, it happens in both this TCP and UDP, right?
Sorry, can you repeat again?
This segmentation process, it happens in these both protocols, right? TCP or UDP, or it just happens in TCP?
Yes, yes. It happens in both. It
Both.
happens in both.
Okay. It's a part of transport layer.
Yes. Any other questions? Any doubts?
Yes, is TCP and segments the same?
TCP and segments? No. TCP means it is a protocol. Segmentation means you are dividing your data. Now, what happens is when you divide your data, is TCP UDP playing any role here? Not yet. But when you're transmitting this data, how now, for example, this data 100 MBs you transmitted, okay? What will UDP do? He won't care if this data is received or not. But TCP, he will make sure that this information is received correctly at the user end. If it is not received, he will ask them to send this data again. That is TCP. That is UDP. Segmentation means just data is being divided into smaller pieces. That's it. How you transmit it, that belongs to TCP and UDP. Therefore, it is called protocol. Clear? Okay.
So for both network layer and transport layer, so we use segments.
For both,
Network layer, the third one.
why would you use it for network layer?
So for
Segments are
second one,
used
you said
for,
it was frames, right? What was the third one?
third one was packets.
Oh, packets. Okay, thank you.
Yeah.
We use routers in the third one, right? The
Yes.
network layer.
Yeah. Yes. Now you guys know about DDoS attack, right? You remember DDoS attack? You're just sending a request on the server.
Sure.
Let me closely relate this example. See, let me remove this. Hmm. Now closely look at this handshake. When I am at the sending party, when I am the attacker, and this is the server that I want to attack, I'm just sending request. I'm just sending request. I'm not even giving him time to send this scene acknowledgement. I'm just saying, hi, how are you? Now, for example, practical example. Hi, Roshan, how are you? Hi, Suruchi, how are you? Hi, Aga, how are you? Hi, Manju, how are you? Hi, Pawan, how are you? Am I giving you time to respond? Hi, sir, I'm good, thank you. No, right? I'm just sending my packets. I'm sending SYN packets. This handshake never completes. So this server, this resource becomes exhausted because he cannot respond to it, to these SYN packets. Eventually, he will go down. This is called as SYN flood attack. I'll show you a practical of this. Only SYN packets are being sent. Handshake never completes. Kind of DDoS attack, right? Flooding your server with traffic, not letting him respond. Can you now relate this SYN to DDoS or your transport layer attack to DDoS, right?
So this DDoS attack would use UDP.
Yes, it can use UDP.
So you can
It's
also use TCP.
yes, because is it waiting? No, it's not about the delivery mechanism here. It's about the attack. You're just sending SYN packets. Okay, but are you waiting for that server to respond? No,
No.
you're just sending packets. The purpose here is to just deliver it, not to receive anything.
What
So
is
handshake,
that
this
again?
handshake, to make it a reliable connection, the handshake you want to establish is never getting established. Therefore, it's called SYN flood attack. Sending SYN packets. SYN means synchronization. Okay.
Mm.
ACK means acknowledgement.
Mhm.
Now, for another example, gaming. Okay, gaming uses UDP. In gaming, player positions are important, right? Player positions they update from time to time. So this must be fast. If one packet is lost, there is no big problem. Speed is more important here. So such mechanisms use UDP. And devices wise, if you will ask me, firewall is used at transport layer. Why? Because firewall or load balancer. Because many firewalls they inspect this TCP, they inspect this UDP, they inspect ports, which is layer 4 information. So in short, this transport layer in OSI model, this is reliable for end-to-end communication. And note this thing down, end-to-end communication. It is responsible for segmentation. Reliability means delivering the data to the correct application using ports. So few
Reliable
keywords
for end to
in
end.
this. I'll repeat again the complete definition. Transport layer, which is your OSI model, layer number 4, it is responsible for end-to-end communication,
Mm.
segmentation, reliability, and delivering data to correct application using ports. Are all these terms clear now?
Yeah.
Okay. So which two protocols are involved? TCP, UDP. You know the difference between them now. Okay. Now let's talk about next layer, which is session layer. Let me quickly clean this. Too much of drawing. Oh, see. Oh no. All right. Now, layer number 5. This is session layer. This layer can be confusing. Sometimes students they misunderstand this because this is related to sessions. Okay. When you log in into your Gmail, does your Gmail remember that you already logged in?
No. It's open a new session.
Yes. When you are on this Zoom meeting for 1 hour, how does Zoom know that you are still part of the meeting? Yes, it's been 1 hour, right? You are connected. How does it know you're still a part of it?
The
Answer
session
is
is still on.
yes, answer is session layer. So its job, session layer's job is to establish, to manage, to maintain, and to terminate communication session. That's it.
Mm.
He's like a manager, conversation manager. He's going to establish, he's going to maintain, he's going to
Give me your phone.
manage, he's going to terminate the communication sessions
They didn't drop out
between devices
for
or
that.
application. Okay, a real life example I'll tell you. Suppose you're calling your friend. The process starts by dialing the number, right? You pick up the phone to dial the number. Call starts. Now conversation is happening after the call has been started. After you're done talking, you'll disconnect the call. So someone has to start the call, keep it active, and then end it properly, right? That is what exactly this session layer does. Let's say you open a WhatsApp application. You log into WhatsApp, you chat for 2 hours. After your chatting is done, you close the application. So this session layer it helps you maintain your active session. So you don't need to log in every minute. Before starting this session, Zoom meeting, it is asking you for username password, right?
That's it.
Same way. Session means conversation. So think of session as a communication conversation between two parties. It can be Zoom meeting, Google link, Teams meeting, WhatsApp chat, anything. Starting of your meeting means session is created. We are talking for 1 hour, 1.5 hours, session is maintained. And after 1.5 hours, we disconnect our meeting. Session is
Mm.
terminated, session is closed.
Mm.
These are the responsibilities of session layer. Establishment of session, session maintenance, and session termination. Let me give you a banking example. You log into any banking website. You enter username, you enter password, you do multi-factor authentication, OTP is given, you are verified. This is where your session will start. Okay. Now, after logging in, what you will do? You will check your balance. Maybe you will make some payments. You will transfer the money. You will check your statements. Anything. Once that purpose is done, what is this? This is an active session. Once this purpose is served, what you will do? Log out. What is that? Session destroyed. Session termination.
And if you don't log out, in some
Mhm.
scenarios, system automatically disconnects you or discontinue.
Yes.
Okay.
Yes. So session that is the security mechanism
Okay.
automatically disconnecting you.
Mhm.
But imagine if that banking application keeps on asking you password every single minute,
Mhm.
won't that be irritating,
Yeah.
right? You check your balance, you log in, you transfer your money, you log in, you view your statement, you log in. This is very annoying, right? So instead of what applications do, they ask you log in for one time, that session is created, you use that website, it becomes much easier compared to maintaining this username password again and again. So there is something called a session timeout. The concept which you are talking about, that is called a
Right.
session timeout.
Time.
This is an excellent security concept. So if there is no activity happening for 15 minutes, application will end the session. This is how users are protected. Now, if I tell you what is session hijacking, if I ask you this question, what is session hijacking? Can you relate this? Do you know the meaning of session now?
Yeah.
Yes.
Yes. Do you know the meaning of hijacking?
Yes.
Yes. So, can you try to guess what exactly happens in session hijacking? Attackers, what they will do, they'll hijack your session.
Right.
For example, you have logged into banking application, right?
Long
They'll
deadline.
hijack this session. How they do it, what they do, that is a different thing. Let's not go there. But if I ask you session hijacking, can you easily relate it to this session layer now?
Yes.
Yes.
So maybe like when we log into our bank or something and we forgot to log out during that time, the attacker may just purchase something and make like some transaction or like transfer money or something like that.
What
Hijacking
happens is
transaction
attacker will steal your session
session.
tokens.
Yes.
Okay, that token is stolen, and once that token is stolen, website, they don't care, right? Website thinks he's a legitimate user and they'll allow you the access. That tokens are stolen,
Yeah.
session tokens are stolen. Okay, clear? That is what happens at layer number 5, session. So layer 5 focuses on conversations, sessions, and your login state. That's it. Maintain. If I talk about definition again, session 5, sorry, session layer, which is our layer 5 in OSI model, is responsible for establishing, maintaining, and terminating communication session between applications. That's it. So if I ask you what is a session, what you will say? What should be your answer?
Establishment, maintaining, and termination of communication.
Yes. Session means it is the time in which you are actively participating into that communication. Communication exchange is happening. That is a session. Session timeout means terminating after inactive session. That is session timeout. Okay. So in layer 1, we were moving bits. Layer 2, we are finding devices using MAC. Layer 3, we are finding networks using IP. Layer 4, we are finding applications using ports. Layer 5, we are managing conversations using session layer. Okay. Now, what if two systems, okay, if my system and Suruchi's system speaks different languages? I speak English, she understands Nepali. She speaks English, I understand Hindi. What if our system uses or communicates in different languages? We use different data formats. How do they understand each other? Answer to that is your next layer, which is presentation layer. Okay. Now let's move to layer number 6. One of the easiest layer to understand. This is called as a translator layer. In short, what does the name specify? Presentation. how you present your data. Now, let's start with an example. What happens if a person from India speaks only Hindi and person from Russia speaks only Russian? It will be difficult to communicate with each other, right? You need a translator. Similarly, computers, they also need a translator. That is where your presentation layer comes into picture. So the job of this presentation layer is to translate, format, note this thing down, translate, format, encrypt, decrypt, compress and decompress data so that both the systems can understand each other. I repeat, translate, format, encrypt, decrypt, compress and decompress your data so that both the systems can understand each other. Think of this as a translation or translator layer, language conversion layer kind of thing. While talking about ransomware, we discussed about encryption, right? Encryption and decryption of data. So here, computer example, if I take, let's say a computer sends a photo or a video, maybe text, PDF, anything. The receiving data must understand that format. Presentation layer makes it possible. So it has three main functionalities. This presentation layer, I'll write it here. Let me delete this port. It has three main functionalities. One is translation, other one is encryption, and third one is compression. What do you mean by translation? Suppose you type hello. Humans should see it as hello, right? If I type hello, I will see it as hello. But what are computers seeing? Do you think computer understands these alphabets, English, Hindi, Japanese, Russian language? No. Which language they understand? Zeros and
Digital.
ones.
Zeros and one.
Zeros and ones. Digital, right? Only zeros and ones. So computers at their end, they will see something like this, getting converted into zeros and ones. So presentation layer helps convert this data into computer format so that it can process it. Your computer is not going to understand this hello and all. He'll understand this language. So who's helping in this conversion? Presentation layer. You use these files daily, right? PDF, PNG, JPG, MP4. Presentation layer helps ensure that both the sides, sender and receiver, they use same format. Now, for example, if I share your file tomorrow, it is in MP4 and you are reading it in PDF. Will you be able to see this file properly? No. If I send you a photo, JPG format, and the receiving system knows that this is a image, it will handle it properly with that particular JPG format. So formatting is handled at this layer. Clear what is translation? First one. Now let's talk about encryption. What is encryption? Encryption means you are converting your data so that it becomes unreadable to the outside world.
Hmm.
For example, my password is something like admin123. Okay, this is my plain text password. If I want to encrypt it, I'll use different algorithms and then I'll encrypt it, something like this. After encryption, if it looks like this, will you ever understand what was written? No. So if anyone, like our attacker, if man in the middle attack is performed and if your data is encrypted, will he be able to read it? No. He'll see is this gibberish content. That is called as encryption.
So the star that we get when we enter the password, that's also encryption, I guess, right?
No, that is password. That is you're hiding the characters. But
Okay.
the way you're transmitting that information,
It's called
that is encryption.
encryption.
Okay.
What will happen if encryption is not performed? You know man in the middle attack very well now. Yes. Attackers, they'll easily capture your data and they'll see your password in plain text. They'll see your sensitive card information or session information in plain text. It gets very easy for them to attack, right? But with encryption, it's all gibberish.
Mhm.
Therefore, there is a difference between HTTP and HTTPS. HTTP is a protocol which sends or transmits your data in plain text. Therefore, world moved from HTTP to HTTPS. S is more secured. It uses encryption. Okay. And what happens at the decryption end? You're transmitting this information, right? Let me delete this. Let me show it to you. What is decryption? This is your sender side. Okay. This is your password. This is your value of that password. Okay. You have encrypted it. But at the receiving end, wherever your server is server going to understand what is this nonsense? He'll decline it, right? At the receiving end, it should correctly be decrypted as admin123. Only then you will get permission to enter that server, right? If I'm sending you information, hello, my name is Bhushan. This is the information I want to send over the server or to the communication channel. Hello, my name is Bhushan. Now that is encrypted. At the receiving end, you should see that message properly. Only then you will understand, right? His name is Bhushan and he's saying hello. What if that message is encrypted? Will you be able to understand what is said by me? No. So decryption is also important, similar to encryption. So this decryption happens at the receiving end. Who makes sure it happens correctly? Presentation layer. Last one is compression. Another major responsibility. Compression means suppose you have 100 MB of file. That is a 100 MB file. Without bandwidth or without time, will you be able to send this big file over internet? No.
That's it.
You compress this file and you send it. Don't break it. That is segmentation. Compress it, press it. You will be able to transfer your data much faster. Why do why do we say that on WhatsApp your image quality gets disrupted? Why is it? You try this. Take a photo in DSLR or in your camera. It's crystal clear. And you try to send this to your friend on WhatsApp. Try opening that image on WhatsApp on your friend's phone. Image pixels and that image starts getting blur, right? What is happening? It's your data, it's your image that is compressed. Why? Because it was transmitted through WhatsApp. Will WhatsApp transmit it through original file, like original MB? No, it will try to shrink it so that your transfer is much faster. So your zip files, we have used zip files, right? Zip extensions, they are compression. And to view the original file content, you decrypt it. Who's helping you do that? Presentation layer. So your session layer focuses on managing conversation. Presentation layer focuses on how your data will look. Will it look encrypted? Should it be compressed? Is there translation required? That is what is taken care by presentation layer. Clear? Anything that you want me to repeat here in presentation layer? It's like a decoration layer. I'll instead say this, a decoration layer where you encrypt, decrypt, compress, decompress. That is what this layer does. So what functionality is associated? Translation, encryption, decryption, compression, decompression, all these things. Clear? All good? Let's move to our last application layer. Now, everything you have learned so far was happening behind the scene. This layer, sorry, this layer is the layer you actually see and use. Application layer. When you use your WhatsApp or Gmail, Chrome, YouTube, Zoom, who are you interacting with on your OSI model layer? It is application layer. Name itself suggests, right? Application. You're interacting with an application. So its job is to provide network services directly to end users and applications. The layer that you use is application layer. So imagine you're ordering any food. You order Swiggy, Zomato, or what applications do you have in US for food? How do you
Uber,
order food?
Uber Eats.
Which one?
Uber Eats.
Uber,
DoorDash.
It's
DoorDash.
see, immediately answers are coming. Everyone is active when we talk about food, right? So this application behind the scenes, you have restaurants, you have delivery partners, there is map involved, there is payment system, lot of thing happens, right? But what you see at your end, only Uber Eats. Do you care about what protocol is being taken? How is this information going to the Uber Eats server? Anything like this? No. All you care is about Chrome or maybe that application. Lot of thing happens in the background, that placing order and all these things. Do you care about it? No. Similarly, all you interact is with application layer. Behind the scene, there can be encryption happening, session, TCP, routing, MAC address, signals, so many things involved. So the main job of this layer 7 is to provide services like web browsing, email, file transfer, messaging, video conferencing, all these things. So you have protocols involved in this layer. HTTP, you use it for a browsing, right? It is an application layer protocol. HTTPS, what is this? This is a protocol again used for application layer. FTP, SMTP, DNS, most important protocol taking place at application layer. Do you know what is DNS? Domain name server. Have you heard of it? No? I'll tell you. Very easy. It's called name to IP, IP to name. Note this thing down. DNS means name to IP, IP to name. Now, how to understand this concept? DNS. As I mentioned, we human beings are dumb, right? We don't understand or we tend to forget things. What will be easy for you to remember? A name called Samjana or her security number 1256378892. What will be easy for you to remember? Name, right? So we humans, we tend to remember easy things. So DNS is helping you with this.
Mm.
At the back end, every website is having an IP address, right? Every website, even google.com, they have their own IP address, something like 8.8.8.8. Are we going to remember these numbers for every website? No. Instead, what we remember? Google.com, Bing.com, Instagram.com. So we remember name. It is easy for us to remember. What is DNS helping us with? When you type google.com, at the back end, this name is converted into IP. That is the purpose. You remember in school times or in childhood days, we used to have black color small pocket diary in which we used to write phone numbers of our friends, right? How many of you have used it? Everyone. Even I had used it, right? Why do you have that phone book? There is a name written and there is a phone number written in front of it, right? Why do you write name? So that you remember. It's easy for you to search with name because we are humans. We don't tend to remember numbers. Therefore, we carry this diary, right? Same thing like internet phone book. So DNS is converting your name to IP addresses, your website's IP addresses. There is no need to remember this 142.250.183.78 or 8888 like this IP addresses. Try this whenever you get time today. Take any website. Try to find out its IP address. Google it. And when you type URL, instead of typing google.com or that application's name, you type IP address and see where it takes you. Try
Mm.
this whenever you get time, okay? So clear what application layer does? Something which becomes meaningful to our humans. Your emails, web pages, videos, images, everything takes place at layer 7. Layer 6 focuses on how your data looks, encryption, compression, translation. Clear what is OSI model? What it is helping you with? It is helping you understand your communication, how it is now. It happens from sender side. Okay, sender starts with application layer, goes this way. At the receiving end, it starts with physical layer, and then your end users will see whatever information you have sent them. So this is the flow of it. Clear OSI model?
Mm.
All right. Now time for some quiz. If you have understood the topic, let's see if you can handle this. Tell me, where does encryption happens? On which layer?
Presentation.
Presentation.
Presentation layer. Data unit for layer 4 is
Segmentation.
Segmentation.
segments. Okay. Fast protocol used as UDP is on which layer?
Transport layer.
Transport layer. Which layer is known as conversation layer?
Session layer.
Session layer. Correct. Which layer is known as translator layer?
Presentation.
Presentation.
Presentation layer. Which layer ensures end-to-end delivery?
Transport.
Transport layer.
Transport.
Transport layer. Who sends data in bits?
Physical layer.
Physical layer. Where does MAC address sits?
Data link.
Data link.
Network.
Not network, data link.
Data
layer. Your IP addresses sit on
Network layer.
network layer. What else? Where does routing take place?
Third one, it's a network.
layer.
Network layer. Okay. Which layer is responsible for ports?
Transport layer.
Layer.
Ports.
Transport layer.
Transport.
Where does your ARP operates? ARP. ARP.
data link layer.
Data link layer. Exactly. Because ARP associates with MAC addresses. Remember that. Where does your switches sit on? Which layer?
Network layer.
Data link layer.
Data link layer.
Data link layer. What is the unit of layer 2?
Frames.
Data unit.
Frame.
Frames.
Frames.
One last question. Is hub a intelligent device?
No.
Is switch a intelligent device?
Yes.
Why is hub not a intelligent device?
It's a stupid, dumb device.
Yes, it is a dumb device, but why is it called a dumb device?
Because we did that. You told yesterday that
It broadcasts message to everyone,
everyone, yes,
right? Whatever devices are connected to that hub, it will
it tells
broadcast
everyone.
to everyone. Okay, so clear on this OSI model? This is a reference model, okay? This is like a blueprint of how communication takes place. If you understand these layers properly, what exactly happens on these layers, you can get a good picture of how things are taking place at the back end.